Hello, welcome back to Blender Sushi Live Noding. In this episode, I want to show you the breakdown on how I created this. You're able to do this using the latest Blender 3.2 alpha. So this is still like experimental geometry nodes node, and the one that's responsible is this duplicate elements nodes. Okay, this one is from Johnny Matthews. If you check his Twitter, there's this node, example of this node, how to use it, and it's pretty much the same thing. You can imagine this is like a stack of coins, right? And they are kind of animated and they're duplicated on the fly, and they're actually changing on the fly as well. You can imagine something like a cylinder, for example, and if you are using like an array, and if you are duplicating it in the z-axis, imagine this type of array, and if you create like duplicates, but each of the arrays can have different index value. Okay, so this is basically what's going on, and the geometry nodes make this really easy and simple. So if I show you, okay, so I started with a simple grid 6x4 with a 24x40 vertices. I can reduce this number so it looks much simpler. The animation is coming from the noise. If I get rid of this, if I cut this amount, this is basically the number of array that we are creating. Okay, like a number of duplications. You can put in like random value, like integer 5, between 5 and 15, for example, and we basically like have this. So if you are making like a type of architecture with made of boxes, you can actually easily stack this. Yeah, it's for the building architecture. So let's take a look. Okay, there's this capture attributes, set positions. Okay, if you are just using duplicate elements, it's just gonna be creating duplicates of elements with the index. You actually need to capture the value and pass it. Actually, you don't need to capture it. This is just to output the value. But if you are using it with set position, if you are using the index with set positions, you can offset, you can use the index value to offset the duplications. Okay, so in this case, it's offsetting in the z-axis. So this is a really simple example. And I'm also offsetting it in the x and y. Yeah, I mean in the y directions. I think I forgot. Okay. Oops. Disconnect. X. Okay. It's supposed to be something like this. So x, y, random value, and the z-axis. Z-axis is coming from the index that's been multiplied. Okay, because this is like the same size, but you should get the idea. And I realize it, and then I realize the position and use the point vector positions to instance a cylinder. This cylinder can be anything. You can replace it with cube, and there you go. Stack of cube. You can easily make changes. Oh, currently this is random. In order to make it less random, let's use noise and multiply. Okay, so we have this nice swimming result. Okay, cool. This one is coming from a noise texture that has been mapped. Let's see, just make changes here. -0.1. Okay, I think this is kind of more correct. Okay, noise texture coming in, and this value is being offset by the time. So I'm using this time, and I can make it, I can randomize the speed, make it slower, make it faster. And this one is offsetting the position vector that's being used by the noise texture. Right, so you can change the noise itself. And let's see how, is this currently still alpha? Okay, so sometimes it might crash, but so far has been pretty stable. So this is a lot of cubes, a lot of duplications happening. So duplicate elements is like a kind of like a robust, more sophisticated type of array. So you can actually pass this array index to be used later. This attribute, you can pipe it out. So it's being instant, and you can set up materials. That's pretty much it. Okay, there's another thing. I'm using this without, if I actually use this control options, right click, and then kind of disconnect the flow there. We have just a flat, this is the effects of noise. But if you watch carefully, if I use control options and enable that, suddenly we have this. So this is actually a position value in the x-axis that has been remapped. So we can have this type of like a mountain, because the value is going up in the x-axis. That's why we can have this mountain. And if we multiply this value that's going up in the x-axis, if we have graph, so multiply this with the noise, we have this type of mountain. Let's try reducing the value for now, so it's a lot faster. And let's see, position, you can play around with this, whether you want to plug it to z-axis, so you have different wave, because we are offsetting it from different axis, so you're gonna have like a different mountain, whichever you like. Maybe you like this one. Let's reduce this. If you don't want to use this map range, you can actually, if you don't use like a math and maybe like a sine wave, it's gonna be pretty obvious. Now we are getting sine wave. If we increase the number in the x-axis, you're gonna see mountain of sine wave, but you might need to remap the value here from between -1 and 1 into a different value. So now we have this result. Just increasing the number will give you the mountain. Okay, so I think that's pretty much it. So replace the cube with a cylinder, change the radius 0.1, depth. Okay, we have some kind of coins now that we can render. But I think a more complex application for this is for some type of building. If you want to stack objects, perhaps your stack even have like a different size, you can use duplicate elements. Although maybe it's only duplicating the same elements, you can however use like instancing, because this is like only like a point vector position that we are using. So maybe anyhow, this is still kind of experimental. Again, you need to use Blender 3.2. Still pretty cool to be able to do this very easily. So hopefully this is interesting for you and useful. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.